All right, so this is a walkthrough of that fourth packet of information that I gave you, a fourth packet of notes that I gave you. Begins with the standard normal distribution. So here's your normal distribution curve. The area or the total area under the curve is equal to 1. So everything under this curve is equal to 1. It's symmetric about your mean. Your mean would be 0. Your mean is going to be standardized at 0. So when we do our conversions, when we talk about these scores and everything, your mean will always be in the middle and it will be standardized as 0. And your standard deviations will be standardized as being 1s, going back to your empirical rule. And so everything's symmetric about your mean or about 0. So everything to the right of your mean reflects to everything that's on the left of your mean. So if everything under the curve is equal to 1, that means half of your data, or 0.5, is to the right, half of your data, or in other words, 0.5 is to the left. Key phrases that we're going to use would be less than, lower than, below, and colder, some things of those nature. They always represent to the left of, greater than, right, more than, above, and hotter, or certain phrases of that nature will always represent to the right of. So just going back to the generic number line, if I look at the number 1, everything that's greater than it will be to the right of it. Everything that's less than it will be to the left of it. If I look at -3, everything that's greater than -3 will be to the right of it. Everything that's less than -3 will be to the left of it. All right, so we're going to use our z-scores. We talked about z-scores already. We're going to actually use the application of z-scores. Remember, it's your data value, the data value in question, minus the average, your mean, divided by the standard deviation. So that's always going to be the process to standardize your data value, or in other words, to convert it to a z-score. It's your data value minus the mean over the standard deviation. Then we're going to have a z-score chart, which I already sent that to you, in which the way we will read our z-score chart, let's say if we had, and I don't see it up here, let's say if we have 1.57, we're going to round all of our z-scores to 2 decimal places. And so let's say if I have 1.57, the 1.5 will be on the column, or represented on the left column. The 0.07, or the 7 that's in the hundreds place, will be on the top row. So let's go back to the way the z-score chart is set up. It goes from -3.4 to +3.4 on this left column, and then on the top, it goes from 0.00 to 0.09. So going back to my number, if my z-score is 1.57, I take the 1.5 and look for it on that left column, and I look for that 7.07 on the top row. So 1.5 will be over here, 0.07 will be on top, and then where they meet would be the area that's to the left of the data value that we're talking about. The chart that we're using will always represent what's to the left of, or in other words, what's less than. So I will have a data value that I'm going to convert to this z-score. That z-score will represent the data value in question. And then the number I get from the chart, which is 0.9418, will represent the amount of data from that normal distribution that's less than or to the left of that data value. So if you convert to a percentage, that's 94.18% of the data is less than the data value in question. All right. If I want to know what's greater than it, then what I would do is subtract it from 1. In other words, greater than represents what's to the right of. The chart will always give you what's to the left of. If you want to know what's to the right of, remember everything under the curve is equal to 1. So if 0.9418 is to the left of that data value, that means when I subtract it from 1, I get 0.0582. That means 0.0582 will be to the right of it. Remember, all of this, or both of these numbers, have to add up to give you 1. So greater than, if I want to know greater than, using the chart that we have, I will always subtract my chart value from 1. Not the z-score, the chart value. All right, so less than, if I have -2.04 as a z-score, I look for the -2.0 on that left column. I look for 0.04 on the top row. Where they meet at should be 0.0207. Greater than 0.82, so I look for 0.8 on the left column. look for the 2 on the top row. They should meet at 0.793. Now, don't forget the chart value is always less than or to the left of. The first question asked about less than, so that value was good enough. The chart value was good enough. But the second question asked about greater than, so that means I need to take the 0.7939 and subtract it from 1 to get the value that's greater than. In the third scenario, negative 2.11 and 2.5, you want to know what's between that, or how much data, or the percentage of data, or the proportion of data that's between negative 2.11 and 2.50. So what we would do is we would find the chart value for each one of those values and then subtract them from each other. So the chart value for the negative 2.11 is 0.0174. The chart value for 2.50 is 0.9938. So I do the 0.9938 minus the 0.0174, and that's 0.9764. So that means 0.9764. The proportion of 0.9764 would be in between these two values, or in other words, 97.64% would be between those two values. So we only have 3 scenarios. We have less than, wherein I would use the chart value. Greater than, I would subtract the chart value from 1. And then between, I would subtract the 2 chart values. Notice everything that I'm using, or what I would calculate with, or what I'm considering my answer, are the chart values. The z-scores are not what we calculate with. The z-scores help us to get the chart value, then we calculate with our chart values. All right, so let's look at the application of these men's heights and normal distribution with mean of, are normally distributed, excuse me, with the mean of 69.5 inches, standard deviation of 2.4 inches. It says the Gulf Stream 100 is an executive jet that seats 6 and it has a doorway of 51.6 inches. What percentage of adult men can fit through the door without bending? So the data value in question is the 51.6. We're talking about the percentage of adults that can fit through the door, which is 51.6 inches without bending. We want to know the percentage of adult men that are shorter than 51.6. If they're taller than 51.6, then of course they would have to bend down or stoop down. But they give us the mean at 69.5, standard deviation at 2.4. And once again, the data value X is 51.6. So plug that into your standard deviation formula. 51.6 minus 69.5 divided by 2.4 gives you negative 7.46. So this wasn't the best example to start off with, but this is one of the ones they gave in the book initially. So we just went ahead and went with it. So the chart value is 0.0001. That means a percentage of 0.01 men can go through the door without bending. So virtually no one can go through the door without bending. So like I said, that wasn't the best example to give, but that's one of the initial examples they gave, so we went through it. So let's do another one. The U.S. Air Force requires that pilots have heights between 64 inches and 77 inches. Find the percentage of men meeting the height requirement. So we're talking about between 64 and 77. So they gave us the mean from the previous setup at 69.5, standard deviation at 2.4. First data value, 64 inches. Plug that into your z-score formula, gives you negative 2.29. Second value, 77 inches. 77 minus 69.5 over 2.4 gives you 3.13. The chart value, go to the chart. Remember, the left column will be negative 2.2. Top row is 0.09, and that will meet up at 0.0110. For the 3.13, you look at 3.1 on the left column, and then 0.3 on the top row, 0.9991. Subtract those values, that's 0.9881. So 98.81% of men will fit the requirements. Next one, what percentage of men would we expect to be taller than 70 inches? So once again, standard deviation 2.4 with the mean of 69.5. Our data value in question is 70 inches. We want to know about someone being taller than that. 70 minus 69.5 over 2.4 would be a z-score relationship. That gives us 0.2083. Don't forget, when we calculating our z-scores, we're going to go to 2 decimal places, so that's 0.21. Go to the chart value. 0.2 would be in your left column. 0.1 would be on the top row. That gives you the chart value of 0.5832. But remember, we want to know about taller than or greater than, or what's to the right of this data value. So that means we're going to subtract it from 1. That'll be 0.4168. So 41.68% of men we should be taller than 70 inches. All right. Let me know if you have any questions.